Okay, we're recording again. So yeah, at this point, I never answer my phone. Never answer my phone unless the caller ID says it's somebody I know. So okay, so where was I? All right, so it ran. How many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. Are you shocked? You should be shocked because the 11th one is the null pointer. Let's come up with a hypothesis to explain that after I do the following. So we have one member, age. I'm just going to increment age. Now, it doesn't matter that it's irrelevant that it is uninitialized. Who cares? It'll be garbage being changed into garbage plus 1. Who cares? Okay. So now it's in there. The only difference now is I'm going to touch something inside the class. There's my crash. A lot of you saw segmentation faults, core dumped. Okay? So let's go over there are two pieces of information there: segmentation fault and core dumped. So the first is, what does segmentation fault mean? An early technique for allowing more than one user to use the computer at the same time is a way of virtualizing memory. So prior to virtualizing memory, only one program could execute on the computer because one program would be loaded into RAM and it would take all of memory. So only one could run, and it would run until it was finished. Okay? So computers were just way too expensive to waste in that fashion. We all wanted to be able to run many programs at once, but we still have to provide the illusion that each program owns all of memory, because that's what operating systems are. They are cheap magicians. They are the software equivalent of somebody with a card table on the street with 3 cards, and you got to find the queen. Okay, that's what an operating system is. It's a cheap magician. So what the operating system wants to fool you, your program, into thinking you own the whole CPU, into you thinking you own all of memory, and thinking that you own all of the disk. And in reality, you don't, and you don't. It's all an illusion. So one of the techniques that was invented is something called segmentation. Now, I've drawn the picture many times, but let me draw it one more time. And the picture looks like this. This is what memory looks like when your program is running. So this is your illusion of all of memory. And down here we have the stack. That's where the local variables go. Stack grows like this. This is your heap, where all the dynamically allocated memory goes, and that grows this way. This is your code and your global variables. And whatever I have not labeled is houses dragons. So here be dragons. There's this big region here, and also dragons. Okay, so you never want to poke a dragon. So no dragon poking. Okay, So let's try and find out. So each of these was called a segment. This is a segment, this is a segment, and this is a segment. So that's a segment, that's a segment, and that's a segment. Whatever is not a segment is filled with dragons. Right? So a segmentation fault means that you tried to access memory outside one of these segments. So that's what segmentation fault means. And now we'll figure out how you did that. Let's move on to the second clause, core dumped. In the early days of computers, early days of modern computers, memory wasn't called RAM, it was called core. And the reason for that, I have not brought in core memory, have I, in this class? Okay, I can do that. It's called core for a very simple reason, is that memory was constructed of very, 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 very tiny beads called cores. They were beads that looked like a donut, a torus, and they were magnetic. And memory of that type was actually handmade. So I'll bring it in. You'll look at it. You'll actually be able to see. Have you ever seen one bit? Have you ever seen a bit? I'll bring in the core memory, and you can hold it up to the light, and you'll actually be looking at bits, individual bits. Okay. So core would be dumped when a program would terminate abnormally. So what that meant is that you take a copy of all of memory and write it to a file. So remember that the amount of memory involved is very, very small. I mean, tiny compared to today's standards. So it was small enough that you could make a copy of the crashed program and write it to a disk, write it to a file. And it was called a core file. The purpose of doing that would be to allow you to do an autopsy on the dead program. Now, so start paying attention here, because, wake up. So notice I do an ls, there's no core file here, and I'm gonna run it, and it says that core has been dumped, and there's no core file here. So on real Unix and Linux machines, the core file would be located in your current directory. And it's not the case on the Mac, which is not a real Unix or Linux machine. It's, Apple, as they said in 1984, they said, think different. And when there's a standard that everyone agrees to, except them, to do it this way, they have to do it that way so that you pay more money. Right? Okay, so why does every Macintosh have every new Macintosh has a different power connector? Right? Okay, so I mean, here, even this is the first MacBook Pro, and for $30, I could buy this and adapt it to the next MacBook Pro. So screw you, Apple. So pay attention. By default, the maximum sized core file you can write is 0 bytes, so it doesn't write it. So let's turn on your ability to collect these postmortems, these core files. So pay attention. You limit core files -c unlimited. That's because I set it to 0. Okay, so hang on for a second. Let me see. Will this work? Okay, so let me do this and start again. All right, so don't pay attention to that. Pay no attention to the man behind the curtain. All right. Let's try try this now. U limit dash C unlimited. Okay. All right, so that's the correct result. Let me go back to, so notice there's no core file. I'm going to run the program and find it to crash. Core dumped. Now there's a file that's named core. So that's a copy of memory of your program at the instant it crashed. So now we can do an autopsy, a post-mortem, using GDB. Now, you've all been using GDB. Most of you have no idea you were. When you're debugging Visual Studio Code, GDB is actually the debugger being used. It's underneath the hood. It's just being hidden from you. But let's use it directly. Okay, so pay attention, make notes, because we can't count on this recording. So GDB, you tell it the name of the program, a.out, in this case, and then give it the core file. All right, so it's already told me enough to know what the problem is. Let's talk about it. You'll see if I do it here, then maybe it'll be recording what I'm pointing to. So here, well, first of all, the zero is important. It says the 0th frame, this is the frame in which it crashed. So by frame, it means the function that you're in. Because here, there are 2 frames, because you're in main, and main called bar. So bar is where you crashed, it's frame 0, main is frame 1. We'll look at that in a minute. So notice it says exactly the line number, and indeed it actually prints the line. It crashed on accessing age. There's another piece of information here. The this pointer. So this is 0. It's a null pointer. Okay, so I know exactly what went wrong here. I just have to explain why it went wrong. Let's look at the backtrace. BT. Sorry about hitting it multiple times. So frame 0 is where you crashed, and then the higher numbered frames, you could be several layers deep. The higher number frames are who called who. So on line 32 is where you called bar. And bar crashed on line 16. It tells you the name of the file. So let's look at 32. And there you go. There's the call to bar. And then line, what did I say it was? 16. There's the crash. Okay. So how do you know that it was a null pointer? Come back here. The this pointer is 0. So somehow you were dereferencing 0, the address 0. Now let's come back to this picture. Where is address 0? Dragons. Yeah, don't poke the dragon. So that's why this dragon zone is up here, because dereferencing 0 is so common. So they put that there to cause you to crash, because it would be far worse not to crash and live with the bug. Okay? All right. Now, let's get back to the question, why didn't it crash until I put that code back in? So when it was like this, it didn't crash. Any ideas?
Trying to access this numbers.
Exactly right. Right. So printing out, this could be done without touching the dragon zone. But this is the first time that it would be dereferencing, actually going to touch memory that was part of a bad pointer, based off of a bad pointer. So that's why it crashes when age is being touched. Okay. Okay, so we did that as a range-based for. That's not how many of you did the cross-iterating in Fleet. Many of you did it this way, which is equally valid. Auto IT equals v dot begin, and many of you had the following: v dot end while it was less than or equal to v dot end, and then it plus plus. We need a brace and one change down here. Alrighty. So many of you had this, and you got the same result. So let's compile it. All right, what I wanted to show you before, I know that the last time I did a G and a plus, if you go back in history, the last time I did a G and a plus was the compiler. So that was a quick way of typing it in. If I had just said G, it would have gone to GDB. So G plus, though, was G plus plus. Okay, let's run it again. And there's the crash. What's your bug this time? Yes, but why? Why did you get there? Actually, I'll double dog dare you. I'll take that out. So now there are no null pointers, right? We have only good pointers. Still crashed. Why? So this is code that many of you had. Okay? The problem is right here. So less than or equal to end means you're including end. But end is beyond the valid entries in the vector. That's how you're getting the null pointer. So simply removing that cures the crash. Yes, let's talk about not equals. This question came up in the other section, and it's a very interesting answer, if I do say so myself. The not equals also works. In fact, it's a more general solution than the less than, right? Because some containers don't have an order. Some containers are unordered, so less than doesn't make any sense. However, if it has a .end, you can always test against .end. So not equals always works, no matter what container it is that has .end. But the less than only works with containers that have an order. So this is, in some ways, people would argue this is even better than the less than, although both work for a vector. How are we doing? Okay. Let's do another thing. For, okay, what is that? Or I'll write it differently. Okay, what's that? That's an infinite loop. Now, what sucks about an infinite loop is You have no idea where your program stopped. But that's kind of a giveaway. So let's do this. If rand mod 10 equals 0, so we'll pick one at random. Let's comment that out. All right. Let's compile that. And it worked. And I'm getting the same random number each time because I didn't call srand. So let me modify the code a little. C time, right? And then let's set the random number generator. Look good? Okay, so now I'll get a different set of random numbers each time. Uh-oh, didn't quite work that time. So what sucks here is I have no idea where it stopped. So, and in fact, let me try running it again. All right, run it again, run it again. That time it worked. Like now I'm totally bewildered. So let me show you a useful debugging technique. I'll put that in there. And so what I did there is I bracketed, I said I entered a function and I'm leaving the function. And the utility of this is it worked. A, you know that it worked because it exited. And B, look, it's just like a submarine and an airplane. If I do it here, it should record here. The number of times that you entered equals the number of times that you left. You know, if your number of surfaces of a submarine does not equal the number of dives, you have a problem. Okay? So let's try it again. There's my smoking gun. I know exactly where the infinite loop is. I entered, but I didn't leave. Okay? Good technique, huh? One more debugging technique. You have an intuitive sense of what binary search is, right? So you do like a binary search every time you open up a paper dictionary, which have, okay, how many people here have never opened a paper dictionary? How many people have never opened a paper telephone book? Okay, so they do exist. So let's say you're looking for, I can't say Jackson because he's in the middle of the alphabet. So, and I can't say Kubler because you're in the middle of the alphabet. Okay, Dylan. So we're looking for Dylan, right? So I open it up in the middle in the phone book, and I look at what page I'm on. I'm on Jackson. So I say, okay, C is this way, so I go here, and now I'm on G. Okay, C is this way, and I keep dividing. That's binary search. No rocket science there. So let's say you have a really big program, and you have an infinite loop. It just doesn't come back. You don't know what's going on. You can apply this technique that we just talked about, entered, leaving, in a binary search kind of way. So you could surround basically half of your program, and if it still hangs, if you have entered and leaving and they balance and it's still hung, you go to the other half of the program. And then you keep dividing it down and down and down until you find just the one function that you enter but you don't leave. Make sense? Yeah? Okay. Any questions? Okay, so let's talk about log files now. Now, in the original formulation of the project, you remember I had log files, but it was very confusing, so I took it out. Now, a log file is needed because in the curses-based program, curses takes over your console, so you can't see reliably what your printouts are. But I still want to make use of the powerful, powerful tool of printout for debugging. So I can't send it to the console, but I sure enough can send it to a file. That's the log file. So let's do that. I'm going to cheat a little and make it a global variable. Let's see. I need an include. I need fstream, and I'll declare ofstream log file, and I'll come over here and log file.open, and it'll be log.text. I'll just give it a name. What's the next thing I'm going to do? I want to close it right here. Okay, so I think what you're saying is if you're going to open something, make sure you close it. All right, so I'll come down to the bottom and say log file.close. But right now I have the chance of closing it if it wasn't open, because I'm missing something right here on line 35. What should I do here? Yep, if not log file is open. Let's print out to the error output. See error, that's better than using cout, because it is an error, isn't it? Okay, so that's a barely adequate error message. And I'm going to return a 1. Now, this is bad style. It's bad style because I now have two places in this function called that returns. Okay, well, I could have done, yeah. So I can return here or I can return here. That's bad form, bad style. So what?
For like a Boolean like function, you could have two different returns that return true, return false. Would that still be considered bad?
I'm not sure I follow.
Like bool size is right, so you can either return true or false. So if size is true, then return true, else return false. That's two return types.
Yes, and that's also earns you 2 points off. Because that's the error that says your inefficient computation of a Boolean. All right, so what Garrett is referring to, I believe, is if, let's say, 3 equal, you wouldn't write this, would you? Wouldn't write that, would you? That's silly. Okay, so then you also wouldn't write this. All right. You see where I'm going with this? Because it would have been, for example, is triggered. You're returning a bool, right? So this is wasteful, and I would take points off, 2 points, not much, but 2 points to get your attention. Because look, this function is a bool. Well, this expression is a bool. Anything that resolves down to true or false is a bool. So I don't need all this. All I need to do is return the bool directly. All this goes away. Okay, thank you, Garrett. But I think where you were going with that, I think you were leading me to this, but what you were originally talking about is I had two return statements, and that's bad style. Okay, but for now, let's leave that there. Now that I have a log file that's open, I can come here and say, instead of to log file, instead of cout, I'll send it to log file. Now I can get debugging information out of a curses program, for example. So let's go here, compile it, and I'm going to leave that there for a minute. And a.out. Whoops. All right, Control C, and cat log file. I entered, but I didn't leave. Let's run it again. All right, so, that time I got almost all the way through before I randomly hit the infinite loop. See? So that's the idea of using the log file in a case where you can't print things to the screen. Any other questions? Any questions about this? Let's do something else. Let's make a second file, and it'll be, I'm going to split this program into two files now. So here's class, and this is going to be the include file. Don't ever, if I see somebody else include a CPP, I'm not saying you'll get a 0, but I shall be very, very cross. All right, so pragma once, and include a vector because I'm using vector and I don't want to use a namespace, so that's going to be std : vector. All right, so that's good enough for the include file. And now a CPP file, which is going to be, I'm going to need absolutely foo.hpp. I'll probably need something else. Let's call that foo.cpp. And now let's take, this needs foo. And let's take this out and this out. And move it here. So let's see, but I've got a problem. Well, first I can fix the vector using namespace std. That'll fix vector. Well, what about log file? Oh, I'm using endel. So let me include fstream. And that fixes endel. But what about log file? Where is it declared? In main. How do I get it here? Then I would get, if I put it in, if I declared it in two places, I would get a duplicate. Well, this one's including foo, and this one is including foo, so I'd get two of them. No, it's not part of the standard namespace. Okay. So when you have a global variable, and it's global because it's not inside any function, method, or class, you want to access from another file, you use the following syntax. So let's save that. Come here and say, when you compile this log file, when I refer to log file, it's an OF stream, but it's not found here. It's found someplace else. Okay? Now let me change my to, all right, so I still have the warning there. That would be 10 points off, folks. 10 points for a single warning. Okay, so now you've just learned something else. You learned how to use extern. So now, if I had streamer, double streamer, sparkler, palm tree, they're all in separate files. Each of them could say extern OF stream log file. And then all of your logging information will be collected into one place. Now, the way I put it in the original spec, it was not a global variable. Instead, it was passed as a parameter. And in fact, it was a pointer to an OF stream. So that made the logging optional. It would be optional. If this was a pointer to a log file, I would have an if statement that would output to the log file only if the pointer was not null. So that's the difference between what I originally said and in this original spec and the what I'm showing you here using a global variable. Okay. Anybody have any questions? These have all been debugging techniques. Yeah.
The program after that's not the question generator. It doesn't have any game.
It has a breakpoint, so when you run it under the debugger, it stops.
The program keeps going, but it says for the debug.
Okay, I would look through your various code files in the editor. Look for a little red ball on the left. Also, you could use this. Remove all breakpoints or disable all breakpoints. Kai, I thought you were going to remove your head. Yeah. All right. Now we only have a few minutes left, and this is a liberal arts college, so let's do a Kai. Yep, let's do a Kai. This is exactly what you look like. Give me a moment. Here we are. 1898. See, that's exactly what you look for. Okay, so this is 1898. This is George Méliès. And basically, all special effects, visual effects invented started with him. Exactly. Yes. Voyage to the Moon. Right. So let's talk for a moment about Méliès. Um, he was a magician. In fact, most celebrated magician in France at that time. He went to an early picture show. It was the Lumiere brothers. By the way, so Beauty and the Beast, isn't there a candelabra named Lumiere? Right. Okay. So play on them. So he went to a show, an early exhibition by the Lumiere brothers, and Méliès was so captivated by this invention that he ran up to the front of the room and he said, "Hey, can you sell me a camera and sell me some film? I want to make movies too." And they said, "Screw you," probably just like that. They said no. So what did Méliès do? Because he was a really, really smart guy. Invented his own film, invented his own camera, invented his own chemistry, and started making movies. And while a breakthrough film, at the same time that a breakthrough film was, and you can look this up, a train, a locomotive entering a station and leaving the station. That was it. And people were stunned. He was doing this. So man was light years ahead of his time, and also his tomb is there's a GoFundMe right now to restore his tomb because it's fallen into disrepair. So I would be doing a disservice if I didn't GoFundMe Méliès. Okay. Méliès. What? Yeah. Tomb. Grave. Yeah. So it's a Kickstarter, and let's see how it's doing. So it's got 42,000 euros of a 36. It's going to happen. So good for him. Right. So that's his tomb, and that's what it's going to look like after they fix it. Because right now it's looks like that. No, that's residue from brass falling down. That's the patina of the brass falling down, and it's broken. So if you have a couple of euros to spare, yeah. Okie doke. So everybody's clear. The due date is now a week from now. Yeah. Yeah. I've given you the program. Yeah, I did better than giving you a video. I gave you the program. Okay. It's a zip file.
Yes, I have the zip file, but I don't access.
Okay, so you would let's say there's zip main.s. Okay. So now I have a zip file. Right. Then you say unzip unzip main.zip, and it would inflate it, and then you would just run it like you would any other program. // give it its name. No, that was just a file. I think it's called FW. Has anybody tried it?
I was trying to do that, like that exact command was like saying like FW, like added.
When you do an LS, Not in the Mac because the Mac is stupid. All right. So if you do an LS in the VM, if it's allowed to be executed, it'll be in green. You see the different coloring there? So another thing that you'll notice, ls minus L, the only one that has X's is the one that's in green. So just write this down. If the executable does not have a different coloring in ls, or if you have no colors, do an ls minus L, and it does not have the X's, then just do this. chmod 755 and the name of the program. And that makes it runnable. Okay?
I got a question about the compiler assignment.
Okay, so have a good weekend, everybody. And like I said, I was very impressed last night at the barbecue.